Thank you. That's so exciting and interesting, especially for those of us that self-identify as nerds and really want to dig in there. Let me just change pace for a moment. Matt, you've been talking a lot about error rates as we walk through these metrics. And I guess that brings up the question of how we thought about how to assess the level of error that's allowable in this system. And of course, on the flip side, how we're ensuring that enough privacy is inherent in the system to protect respondents' information. Michael, I know you were a key part of the team that was thinking that through. Can you talk about how you came to a decision about what level to set that privacy accuracy dial at, and what it means for the main use cases of the data set that will be released in August and September?
Absolutely, and it's a difficult balance because you need to make sure that you're introducing enough uncertainty to protect individuals' privacy and the confidentiality of their data, while also ensuring that the data are accurate enough for their intended uses. I already talked about many of the changes that we made to the algorithm itself that led to accuracy improvements. But in terms of setting the privacy loss budget, that point on the spectrum between perfect privacy on one side and perfect accuracy on the other, we needed some sort of reference point. We needed kind of a concrete, fitness for use standard to evaluate against. And so the way we developed that for the tuning runs that we were doing was to start with the primary use cases for the PL94-171 redistricting data. And that's for the purposes of redistricting and for enforcement of the Voting Rights Act. And so with those statutory use cases at the forefront, we conferred with attorneys at the Department of Justice's Voting Rights Section and with redistrictors and civil rights groups and others on what their concerns were regarding accuracy for this data product. And based on the feedback that we got from those data users, we established a standard that we would use for the experimental tunings that we were doing for this demonstration data release. And so kind of the key things that we learned from that feedback was that for these statutory use cases, kind of the key data elements that people were interested in were total population counts, total voting age population counts, and the proportions of racial groups for unspecified geography. So for voting districts or congressional districts or precincts or wards or towns that we may not know what the boundaries of are until after the census. These off-spine geographies that I was referring to earlier. So with those data elements and geographies in mind, we established tuning targets that we ran to ensure that we would be able to meet sufficient accuracy for both on-spine and off-spine geographies for those data elements. And one of the specific tuning targets that we used was to ensure that for any on-spine or off-spine geography that has at least 500 people in it, we wanted to ensure that the largest racial group for that geography as a proportion of the total population for that geography, that largest racial group will be within 5 percentage points of the enumerated value at least 95% of the time. And so that was one of the driving accuracy targets that we used for that tuning that led to the production of this set of demonstration data. Now, in reality, we actually far exceeded the targets that we set. So as I said, we were looking for that kind of 5 percentage points in the proportion of the largest group, at least 95% of the time for on-spine and off-spine entities that had populations of between 500 and 549 people, so very, very small voting district size entities. In reality, for that kind of size level for the 500 and 529, we ended up hitting those targets 99.5% of the time, so 99.52% of the time for off-spine places and other off-spine entities. And then as those areas get larger, as the population size gets larger, those with larger populations actually perform even better against those standards. So those were the targets that we set. We're eager to have our data users kind of go in and evaluate the demonstration data at that level of accuracy and get back to us. And does it meet your use case fitness for use needs, or do we need to do a little additional tuning to better make it meet those needs?
Yeah, thank you for that. And just a follow-up question on that, Michael. I know, Matt's just walked us through all these other ways of looking at quality, and you talked about a bunch of other changes to the algorithm. Just for clarification, those accuracy targets, was that the only thing that you were looking at when you were looking at sort of how the algorithm was performing, or was it a kind of a broader spectrum?
Oh, those were not the only things we were looking at by any stretch of the imagination. We were looking at a wide array of accuracy measures, many of which Matt walked through in his presentation before. Those were some of the primary ones that we used for the geographical tuning of the algorithm, certainly, because those reflect the statutory use cases that we know we need to be considering. But we were also looking at an assortment of racial statistics, Hispanicity statistics, looking at population counts at various levels of geography, all with an eye towards, are we getting sufficient accuracy for that level of privacy protection? Also recognizing that the data that are going to be included in the PL file will also then be reflected in subsequent data products. So we have to make sure that the level of accuracy that we're establishing now will support the level of accuracy that's going to be needed in those subsequent data products.